Hey guys, we're gonna do Target A day 1, and so that is going to be on page 5 in the note packet. If you weren't here, I did move the quiz so that it's going to include Target A as well, but I'm going to make the factoring part much shorter, so we can talk about that more in class if you missed it. But which is a good thing because Target A I think you guys will really like. But we are going to talk about end behavior today. But in order to get to end behavior, we need to talk about a few terms we have heard before. Don't be afraid of all of this highlighting, or not highlighting yet, but what I'm about to highlight. Don't be afraid of any of this. I will explain what each one of that means. We're just going to make those numbers here in just 1 second. But when we have some sort of function that is being raised to a power, so pretend we would talk about an example 2x squared, let's just say, right? The coefficient, what we call the coefficient, is going to be the number in front of the letter. So in our case, let me erase that highlight. In our case, the coefficient is going to be a. In real terms, it's going to be a. Let me write in red, a, which is the number in front of the variable, and a variable is just a letter. So the number in front of the variable slash letter. That's what that means. Okay, so in our example, the number in front of the variable or letter is 2. Okay, so the coefficient is the number attached to the letter. The degree is going to be the little exponent. The exponent is the tiny number. So in practical terms, it's going to be the n, whatever number is n. And let me change this to a dark blue. N. And it's the exponent, which is called which is the tiny number to the upper right-hand corner. So tiny number. Okay, so we have that. And in our example here, which this is not good to make that 2 because they're going to be the same. But if I had 2x to the third power, the tiny number or the exponent would be 3 here. So that's just the point I'm trying to get across. All right, so we are going to talk about a lot the degree and the coefficient. Now, if I have a function with more than one power where this all right here, we can just give this an example with numbers instead of the practical terms because that's really hard to follow. This is just saying if I had something that was like 3x to the fourth power plus 4x to the third power plus 5x to the second power plus 2x minus 1. Let's just say I had that. That's what this is saying. This is saying if you have a long list of, you have a function with a lot of powers, you have it's going in order from least to greatest, or from greatest to least in terms of their degrees. So my leading coefficient of 4, or my exponent of 4, then 3, then 2. If there is no exponent, we pretend that there's an exponent of 1 there, right? And then this has no exponent at all. This has no exponent over here because there's no variable. Exponents are attached to the variables or the letters. So in this case, the leading coefficient is going to be the first term with the highest degree. So the leading coefficient is the first term with the highest degree. With the highest degree. And so our first term with the highest degree, the degree, remember, is the tiny number, is going to be 3x to the fourth. And the leading coefficient, remember, coefficient's the number in the front of the letter, is going to be 3 here. So it's the number in front of the variable that has the highest exponent. And again, the degree is going to be the number